Hello! In this video we're going to be looking at this gorgeous shape here and thinking, why does this feel a bit similar? So the question is, what fraction of this regular hexagon do the equilateral triangles cover? And this question was sent to me by a colleague, but comes from this Twitter handle on Twitter. This question shows the power of not actually calculating exact things and instead using the similarity of shapes to get to an answer. So here, I've drawn this hexagon out again. And what I'm going to do is I'm just going to mark the 6 equilateral triangles that build the regular hexagon. So a regular hexagon has 6 equilateral triangles. And we can see that actually we have another 6 equilateral triangles here. So because they're all equilateral triangles, clearly these little equilateral triangles are going to be similar to the big equilateral triangles, which means we can find scale factors between their lengths and their area. So let's try doing that. We can see that this is the length of one of the big equilateral triangles. And it is made by 1.5 of the small equilateral triangles. So if we say that the small triangles have a length 1, small triangles have a length of 1, the big triangles are going to have a length of 1.5. So that is my linear scale factor. I just need to times the length by 1.5 to get from the small equilateral triangle to the large equilateral triangle. So what that means is that my area scale factor is going to be 1.5 squared, which is going to be 9/4. For that I just did 3/2 squared. So the area scale factor is 9/4. So whatever the area of this little guy is, this area is going to be 9/4 times as much. So the key thing here is we don't actually need to find the area of this little triangle because we're just working out what fraction of the overall hexagon is it. Now, because we have these 6 little equilateral triangles here and we have 6 bigger equilateral triangles here, actually we can just look at the whole area of these 6 pieces together. So to get from our 6 small triangles to our 6 big triangles, we're just going to times by that 9/4, the area scale factor. So if we imagine that the smaller triangles have an area of, let's say, 1, the bigger ones have an area of 9/4. So actually, the fraction of the regular hexagon the equilateral triangles cover is just going to be the small triangles out of the big triangles. Small triangles out of the big triangles, which is just 1/9/4, which is just 4/9. So actually we just used scale factors to find this. We didn't need to find individual areas. The fraction of the regular hexagon that these equilateral triangles cover is 4/9, which is a lovely solution where you use the similarity between the shapes as opposed to actually finding each individual area. Now, we've seen this in a question recently. This question came up in the Intermediate Math Challenge 2021, and we looked at it in another video. And actually, while I was doing it in a speedrun, I struggled very hard because I actually tried to find the area of each shape and the length of each shape, but all I needed was these scale factors. So try this question yourself, and if you want to find the answer, you can follow the link in the description. Thank you for watching.